Anyway, I'm Glenn. We'll be talking about awesome Azure authentication adventures. If you are familiar with Azure AD, app registrations, client certificates or client secrets, Microsoft Web Identity Library, what else? Daemon apps, calling APIs from other APIs, getting tokens. If you're familiar with that, you're in the wrong room. So go find another room. You'll be bored. If you don't know what those things are, welcome. We're going to have fun, I hope. So we're going to talk a little about Azure Active Directory. We're going to talk about how to sign in users in a web app, calling APIs from other web apps, protecting your APIs, and we're going to touch on something called managed system identity, and we're also going to talk about daemons. We're going to level set a little bit. There's some terms we need to get in place for everyone to follow along. Does anyone know the difference between authentication and authorization? Show of hands. Who dares? You, sir. Excellent answer. You win a chocolate. Excellent answer. So authentication is identity saying, I am me. It is when you walk up to the bouncer at a club and he goes, sorry, sir, you're not getting in here. It's like, yeah, I'm on the VIP list. Really? And you show him your ID and he says, oh, you're actually that guy. Great. Go on in. Otherwise, when you folks at Defrag 20, 30 years ago, when you used to go out to clubs, when you showed your ID to a bouncer, he wouldn't care about your name, he would only care about your age, your date of birth. On your driver's license or ID card, your date of birth is what's called a claim. It is something your identity token, your driver's license, your ID thing, claims to be true by you. Date of birth, so-and-so. And every bouncer had to know in their head, if you were born before that day on that year, then you're old enough. And that's about the limit of the intellectual level of a bouncer. I can say that because I used to be one. So if your claim on your ID, we'll look at the ID, it's like, yeah, that looks like you. You're authenticated. Picture matches, pretty much. Now let's authorize you to get into this club. You are more than 18 or more than 21 or whatever the age limit of that club was. You are less than 30, and you're allowed to get in. That's the authorization part. We're going to talk about both of these things. Back then, you used the driver's license. In authentication, especially for the web, but also many other cases today, we use something called JSON Web Token, spelled JWT, pronounced JOT. Why is it pronounced JOT? Because they said so in the standard. Why? Nobody knows. At least I don't. So a JSON Web Token is a JSON string with claims. That's all it really is. And claims is like your date of birth is a key, and your actual date of birth is the value. So it's a list of key value pairs. All of those key value pairs are claims. The JSON Web Token, the JOT, claims that these things are true about this entity. The JSON Web Token contains two other parts. It has a header, which has some information about how the token is constructed. And it has a last part, which is a signature. Anyone have a vague idea of how public key encryption and signing works? No? You use it every day. You just don't know it. Every day you use public key encryption whenever you go to an HTTPS site. Public-private key encryption is a way of encrypting messages where I have a private key and a public key that are connected. And anything that is encrypted with one key can only be decrypted with the other key. And one is public, so I can publish that. The other one is private, so I keep that private. This is mine. Now, anything I encrypt with my public key or anyone else encrypts my public key can only be decrypted with my private key, so that way people can send me stuff that only I can read. But I can do it the other way around. I can encrypt something with my private key and give you my public key. That way you can decrypt it with my public key, and if you're confident that this is my actual public key, you can be certain that that message came from me and only me. We use this for digital signatures. What we do in the JOT is that we hash the JOT, the text, the key value pairs, and all that. We run it through a mathematical function that creates a string, and then we encrypt that with our private key. And then we attach that result at the bottom of the message. If I now publish my public key somewhere that you can reliably download it, you can verify that not only that this message came from me, because you will run it through the same hash, which hash is specified in the header. And you can also in the header, you can find the key or a pointer to the key. And you can say, okay, I'll go there, I'll download that key, and I'll decrypt the hash, I'll run the same hash, and I'll match those two up. If those match, I get this token, I can be pretty confident that this token came from the right authority and has not been changed underway. This is what makes JSON Web Tokens work. There are a bunch of claims, key value pairs, and I can reliably authenticate this token with its issuer and or authority, and that it has not been changed. Therefore, we can use that from a trusted party can issue tokens to users, and the users can present these tokens to other people or other services. Pretty much like a driver's license. We look at a driver's license, we tilt it, see the magic little reflections. We have our own verification. We don't use public keys and private keys in private because they involve huge mathematical structures with primes and stuff like that, so we don't do that. But it's the same thing. This is the process that happens usually in a process like that. You navigate to some web application. The web application redirects you, in our case, to Azure AD. Azure AD says, hi, who are you? And you type in your username and your password or Windows Hello or in with your FIDO key or whatever authentication methods you have, approve on your phone, all that stuff. Azure AD now takes care of that. That's where your user is. We'll get to that. It will return what's called an ID token, which is a JSON token with some known parameters. As a client, normally in the basic case, my browser, would now present this token to whatever website I'm trying to get into. And this website is familiar with Azure AD. We've hooked it up earlier. So it can go to Azure AD and download the current keys. It can verify the signature, and it can verify different fields or claims, and it can allow or deny me access to what I'm trying to do. It can verify who I am, or it can deny me services based on my claims. So how does this work in practice? Let's look at that. Let me see. Oh, not that one, that one. So this is, we could do all of this just using HTTP client, just constructing requests going back and forth, but luckily we live in a modern world and we don't have to. So let's make this a little bit bigger. We're going to use a library called Microsoft Identity.web. In this case, there are several libraries for doing this kind of stuff. This is based on two standards, OpenID Connect and OAuth 2. They overlap a little bit, but there's basically one of them is identification and one of them is granting access to different services. There are libraries for these for every single platform in the world. If you're using ASP.NET, which I'm going to be using in these demos, I'll be using a library called Microsoft Identity Web, which handles this stuff, but is also tailored specifically for Azure AD. Now, Azure AD, before we move on, let's talk about Azure AD. Azure AD, Azure Active Directory, who's familiar with that? Well, good chance you went in this talk then. So just to make sure everyone's on the same page, Azure AD is called where you have a directory. It is a directory of objects. Users is one object. Machines or different accounts, service principals can be other objects, groups, all that stuff. So list of your users, more or less. Each directory in Azure AD can be connected to one or more subscriptions, which is where you have your resources. There you have your web sites, your functions, your VMs, your databases, whatever. They're all in functions, and they're further grouped into resource groups and all that. The directory is also called a tenant. A user will only exist in one tenant, but can be granted access in other tenants. One company will usually have one directory and one tenant, or they're the same thing. If you have more than that, you're probably the result of a merger or something like that, and you're in for a world of pain. Now, in my tenant, I can register apps. Here I am in the Azure portal, and I've registered a couple of apps here. Because we can't just go put up a web page and start authenticating a user willy-nilly and start grabbing claims every now and then. There has to be some kind of order structure to this. So the first thing you have to do is that we have to register an application in my Azure AD tenant. I've registered some here. Let me just show you how this works. New registration, a name, demo. I can say who can use this. Are you okay in the back? I didn't get a chance to check before I started. Yeah, thumbs up. Who can use this? Accounts in this directory only, which is called Sandcastle. In any Azure directory, personal accounts, whatever. So you're saying what users are allowed to talk or authenticate through this app registration. I'm just going to pick users in my directory. I'm going to skip that. Register. There we go. I've created an app. There's one thing that is important here, which is the application client ID. The application client ID is the username of this app. It uniquely identifies this particular app registration globally. So when I set up an application to use Azure AD, I have to put some information into my web app. Now, again, I'm using Microsoft Identity Web Library, which assumes that I'll have a configuration setting called Azure AD, and I'll have some values here, one of which is client ID. I also have tenant ID, which is the ID of my directory, my tenant. You'll find that on the same page as your app registration. Here, tenant ID. I also need the domain for my app, which is Sandcastle in Norwegian, sandslott.onmicrosoft.com. If you have your own tenant, you might have your own custom domain. But normally, you'll always have the whatever you call your domain, .onmicrosoft.com. That will always work. And I have a callback path. Remember the back and forth graph? If I go with my browser, I'm sent to Azure AD. And along with that transfer, I also have information about where to go next, which is my redirect URL. In this case, it's /sign-in IDC, which is a URL given, it works on this machine because of Microsoft Web. If we go back to Sandcastle and we open the sign-in app, here is the redirect URL specified, localhost port, sign-in, OIDC. So on the app registration, I have to specify where can users be redirected from when they're trying to authenticate to this app. So that means you can't set up a website on evildomain.com and start authenticating as this app. It doesn't work because you won't be sent to it. You'll get an error. So that's part of the security here. And as specified, I want an ID token. There are, in OpenID Connect, there are several what's called flows. We're not going to go into that. That's a whole different rabbit hole. But there are different ways of authenticating based on what kind of client you have. We're going to use implicit and hybrid, so we get ID tokens back. Now, once I put that in, I go to my startup code, and I add these two lines here. Add authentication, OpenID Connect defaults authentication scheme, which is the name of my authentication scheme. It's not particularly important unless I want to have more of them. And I say add Microsoft Identity Web App, which is an extension that comes from the Identity Web library. And I say configuration get section key Azure AD, which corresponds to the Azure ID section in my app config. And then this is standard ASP.NET authentication stuff. I create an authentication policy, which says I require an authenticated user. And I add a filter to all my controllers with this authorized filter policy. This makes it so every request coming into my controllers goes through the authentication filter policy. The authentication filter policy says you have to be an authenticated user. If you're not, it will return an HTTP challenge, which is you need to go authenticate. And it contains the URL to Azure AD. I'm sent to Azure AD, I come back, I get a token into my browser, I come into the sign-in OACD, it creates a bunch of cookies and everything, and then the identity.web library picks that up. So, and that's pretty much it I need to do. I also have these two here, use authentication, use authorization, middleware to actually make this happen in between. So if I run this thing, I get my welcome. And up here is my email address. Did anyone see me authenticate? No, of course you didn't. Because my machine is enrolled in Active Directory, Azure Active Directory, so it has single sign-on. It just goes straight through. Let's take this and go into a private mode. Now you see I'm redirected to login.microsoft online up there with a huge URL. It says sign in. Sure, I can do that. Enter your password. Sure, I can stay signed in. And then I'm in. Hello, GI. And that comes from the regular, which people might know, the login partial, which just at user.identity.name. Because now I've got my token and the Identity Web Library takes this token and populates what's called a claims user. and this thing just works. So let's run this again just with debug. That's okay. So now I'm debugging here, and here's my let's go to do watch. Oh, it doesn't want to do that in the racer mode. Oh well, never mind. Oh, there we go. Let's zoom in a little bit. So here's my user, which is claims principal. It has an identity. And this UI is horrible. Here's all my claims. These are the claims that Azure Identity, Microsoft Identity Web picked out of my token, which is my preferred username and a bunch of stuff that nobody really cares about a lot. Here's my other name. And these things are decoded for you by the Identity Web. You can pick them up and look at them if you want as well. You can add more claims, but the basic scenario, you don't have to. Okay. So that's that. Let's change this a little bit. So we're gonna go into this. Just copy that, and then we'll go back to the app we created, the demo one. And we're going to change to that. So when I do this client here, I copy that client ID, I go into sign in, I put in a new client ID. There, save this. And I need to, in my demo app, specify where I should redirect. This is a web app, and we redirect here. We don't care about the log on, log out, because you can do that as well. Oh, that was the wrong one. That's the one I wanted. And there we go. That should do it. So if we now run this thing, we should end up no thanks. Then I get this one, which I didn't get the first time because I already had that one. This is a consent screen. So when you go through, this is part of the OpenID Connect OAuth standards. Because my app is asking for information. It's asking to know who you are. And I need to consent to that. Because I can't just put up, can't have people just putting up an app and say, I want a bunch of data from all my users. So there's not much info here. It's just called, I could add more info here, but it's called demo. This app would like to view your basic profile and maintain that access. I'm an administrator, so I can consent on behalf of my organization. So that means everyone else in my org that tried to go to this app wouldn't get this screen because I've consented on their behalf. But I'm just going to accept. If I don't, my app won't get the information, and there I'm back in again. So you'll get these consent screens the first time you go to an app saying, do you want to transfer this information to that app? Okay, let's try another example. I want to call an API. So now I've authenticated. I was allowed to log in. It came to, okay, you are this person. Great. Now, I want to protect my API as well. Let's go to startup. And in this case, I want to log in, and I want to be allowed to call an API. In this case, I'll be calling the Microsoft Graph API, which is the API for your organization or tenant. I'm going to get the name. So we do the similar thing here. We add authentication, add Microsoft Identity Web App, configuration section, and then I have another thing here. Enable token acquisition to call downstream API. Again, extension method from Microsoft Web Identity. The thing is, the ID token I'm getting is not allowed to be used to access resources. It can only be used for authentication, but not authorization. In order to access a resource, I need to swap or exchange my ID token for what's called an access token. So I log on to the site. The site gets my ID token, and then my backend service, in this case, has to send this ID token to Azure AD and say, hey, I would like to get an access token for this user. But not only for this user, I would like to get an access token for this user using this app, accessing that particular resource. So it's very narrow. It is this user on this app accessing that resource. In this case, it's me, Glenn, using my demo app, and I want to access Microsoft Graph. We specify this using something called scopes. And I go into my app registration, and I can add what's called API permissions. I can say, these are the APIs you are allowed to call from this app. I can't just call any API. I have to be very specific. I can call Microsoft Graph API, and not only just the Graph API, but I can filter different things. I can say, what are they allowed to collect? In this case, I have the user.read, which is a claim that's a scope that allows me to sign in and read the profile of myself. It is, for instance, different from, let's find users, user.read.all, which allows me to read all profiles. So the access token I'm getting, or will be getting, allows me, I've scoped it down to only give me permission to read from the Microsoft Graph API and my own user profile. If I'm trying to read another different profile, I'll get an error saying I don't have access. I cannot write my profile. That's a different scope. These scopes are defined by the downstream API. We'll check that out in a little bit. So I have to specify when I'm getting a token here. So in app settings here, again, I have the domain, the client ID, the tenant ID, and a little bit down here, I have my downstream API, which I've called downstream API because that's what it was in the demo. It could be anything in the configuration. Has a base URL, and it has scopes. You can have multiple scopes, space separated. I would like to be able to access these different scopes. So I want user read, I want to be able to read all, but write myself and stuff like that. I can add different scopes. So here I can specify, I can minimize here as well. If I'm allowed to access a broad set of scopes, I can in my application say, I could have accessed all of these, but I'm going to access just this one. That's what I'm doing here. And then this is picked up by the enabled token acquisition called downstream API. And here we go, add Microsoft Graph from the downstream API section. And there's the URL for the graph API. And I'm adding an in-memory token cache. Because it would be ineffective to every time I want to do an API call, it would have to do first an API call to Azure AD, get that back, verify the keys, and do all that stuff. That's because and that's why the Microsoft Identity Web has a token cache built in, which will take your tokens and store them in the cache. Because that's another thing, another claim on all the tokens is an expiry date. They're only valid for a certain amount of time. And they can also be valid from a certain time. They can have not used before and expire at. Those are claims in a token. So again, this is the same thing, add authentic user, all that stuff. Let's try and run this one. So what I'm getting here is the same login up in the corner, but now I've got something interesting down here. API result, Glenn Henriksen, which is my name. You don't need to see it, just believe it's there. Let's look at the interesting part is where does it come from instead. So my controllers, I have a home controller. In this case, my home controller takes in a graph service client, which is part of the Graph SDK, which works with the Identity Web. So this is an easy way to get more information from Microsoft Graph. Logged in, I'm authorized for this. And I just call the Graph Service Client, .me.request, get async. That's the way you get your profile. And as I get user display name, this could be anything from my profile. Interesting part here, this thing, authorized for scopes. Scope key section, downstream API, :scopes. It says, this controller expects to be authorized for this particular scope. What that attribute does is that if this controller returns an exception or throws an exception of a type which Microsoft Identity Web determines has to do with you haven't got the right scopes, you haven't got the right keys, it will do an authentication run for those particular scopes. This is part of a thing called incremental consent. Anyone have a mobile phone? Remember when you installed apps, it would give you, this app needs these permissions. And you would go, well, okay, and you'd grant all. But that changed now. Now when you install an app, you don't get that when you install, but when they want to use that particular feature, it says, I need access to your position. Do you want to do that? Okay, great. That's called incremental consent. You can get the same thing in web apps, where you can use a web app with a particular scope, a particular access token that calls an API. And for instance, on the page where you want to make changes to your profile, then you can specify, in this particular case, we're going to need the user.readWrite scope. So instead of granting you a token that has that permission from the start, doing whatever you do when you're just browsing, you can incrementally increase the consent either to more data or more access, and says this particular controller, we're going to need that. And Microsoft Identity Web handles that part for you. It will say, oh, you threw an exception of this type. that I can handle that by incrementing the consent. It will redirect you. You will get a new consent screen. I want access to this. Is that okay? Yes. Come back. The controller runs again, this time without exceptions, and you get the result. So let's call them the graph. Let's call our own API. Now, you might have noticed something. Let's go back to that. I skipped the part here, client secret. Because now I'm not just authenticating against my web app, but I'm asking my web app to authorize me on my behalf. And I need to upgrade my web app from just being a registered app, just saying like, I'm this guy, and everybody goes, okay, sure, whatever, to being, I'm actually this guy. And Azure AD going, okay, I'm sure. Yes, I have the secret to prove it. I have the secret handshake from the Freemasons. Much like light switches in hotels. You have to have the secret handshake to figure out how to turn on the light. And showers in hotels. But I have to upgrade my web app to what's called a confidential client. And I do that by supplying it a secret. It could be a secret or it could be a certificate. So there's an entry here for client certificates, which I can do stuff. I can add the certificate here. I can point it to a key vault. I can do different things. And this is a demo, so I'm being simple. I'm just using a client secret, which is totally fine. Certificates are a little bit more secure, but for many cases, just using secrets are fine. Secrets are defined not on that browser, but this browser. Downstream, certificates and secrets. Here's my client secret. I just go new client secret, and then it would tell me a secret. Test. I can set when it expires. So anyone watching this on YouTube thinking, now they have my secret, don't worry, it expires tomorrow. Way before things end up on YouTube. There's my secret. It is shown, and this is, I don't want to say hello, hello. Listen very carefully, I will only say this once. This only says it once. Copy that secret now. Once you move away and move back, you will never see it again. So copy it, keep it secret, keep it safe. And this has a warning here because this secret is about to expire, because this expires tomorrow. I don't need that secret, so we can just delete that. Here I put this secret in the app settings to show it to you. You should never do that. You should put it in, use the secrets when you're developing locally, or put it in a key vault or some secure location where it can't be easily found and discovered. But for demo purposes, and I know like 5 of you will do that once I showed you, but it's a risk I'm willing to take. It's a sacrifice I'm willing to take that you've screwed up. Right. So let's go to another example. Here's a web API. This is my API, not Graph anymore. Here I just have the Azure AD stuff, my tenant ID, my client ID. I have my startup class, add Microsoft Identity Web API, which acts a little bit differently, because if you're when the first time I accessed the page when I was not authenticated, I was redirected. I got a redirect message, says go there instead, authenticate, come back when you're done. Authenticating a web API is slightly different. Here's the Swagger file, here's the weather forecast, which is the API. Try this out. Let's just execute that. That didn't go too well. I got a 401. Anyone know what a HTTP 401 code is? Unauthorized. So I'm not authorized. It's not very helpful. It doesn't tell you where to go to get authorized or anything. It's like, you have no access. It's kind of the bouncer that just, yeah, you're not coming in here. Why not? Because you're not. He doesn't like your shoes or whatever, and when anybody won't tell you. You have no idea why he's not letting you in. But luckily, we know where to go. So that's a pretty simple setup for that, to deny everyone access. Add Microsoft Identity Web API. And then I have my weather forecast controller that says you need to be authorized. Standard authorized attribute in ASP.NET. You need to be authorized. But here I can also say, I've defined a scope here called access as a user, or I haven't defined it here, but I'm referencing it here. Saying these are the scope required. And I can use an extension method here saying the verified user has any accepted scope and these. If I don't specify which scope, then I would accept any registered users. And how do we do that in the portal? So in the portal here, let's see, Sandcastle API. I have exposed an API, which is a bit broad because what I'm actually doing, I'm just adding a scope. I add a scope and I add a scope name, which can be whatever I want. It can, who can consent to this, only admins or admins and users, and I give it a little bit of information. The scope I've added is this one. Scope name access as user, and I get this really ugly string below, which is the standard. So my API needs a base scope. It is set up here. It's the application ID URI. The default is that it starts with API : / the application ID. It can be anything, but it has to be globally unique. So I can change it to whatever I want, but it has to be globally unique. So if I want it to be something more human readable, I would have, for instance, as a domain I own. I could have api.henriksen.no / whatever, but it will default to that. So access user, who can access? What message do you get when you consent to this scope? Which is, you'll get that in the same consent screen that we showed earlier. Now I also have an app called API Client. In API Client, I can add API permissions. I can go add a permission, my APIs, it will show me my other applications that I've registered that have exposed an API. And I'll say, go to API, and it can select what scopes I would like to access. I've already done this, so it's access as user, which is a scope. And then I see here in the server on my API, as I verify that the user has accepted scope. Now on my client, I also have my domain, my client ID, my tenant ID, and I need a client secret. Because this client is going to access resources on my behalf, and it needs to be a confidential client, so it needs a client secret or client certificate. I have to have those things. I have some configuration. It's put in configuration because that's easy. You could hard code it in if you wanted to. You can get this from app configuration. You can create it by convention, whatever you do, but I put it in because it's easy. Base URL to the site and the scope I'm accessing. The full scope, including the application URI and the scope at the end. So let's take a look at home controller. I get injected myself with a service or with a service called iToken acquisition. It is part of the Microsoft Web Identity Library, which is a helper function for getting tokens. I could, and have done so, and which is why I never do it again, get these tokens by, again, using HTTP client, constructing calls, sending them to the right endpoint, getting back, doing all the stuff, and it's a mess. Web identity makes it a lot easier. The authorize for scopes, again, for handling incremental consent, saying that if you don't have these scopes, then we need to upgrade your access token. And then it's a matter of calling that service. Here I specify the scopes I want is an array, access as user, token acquisition, get access token for user async with these scopes. Token acquisition service will handle the caching of tokens, will check the token cache. Do I have a valid token for this particular scope, for this particular user that is not expired? Yes, no. If not, go to Azure AD, fetch one, send in the ID token, get back an access token, put it in the cache, return it. That's what happens. We log this information, and then I do a HTTP client. I set the header. The authorization header is set to an authentication header value bearer and my access token, which is standard HTTP, how you send a JOT. Normally, you add bearer. Here's the token. Send that as a header. And then connect to get string from weather forecast. There is zero error handling here because it's a demo. You should obviously have error handling and all the stuff you need to do when you're calling third-party APIs. Not do the common mistake of assuming that the cloud is always online, all that stuff. Don't do that. For clarity, that is not part of this. And I just stuff it into view data because I don't need a whole model here. So let's see how this works. First, let's start let's see, what do we have running here now? I have no idea, but let's close it. We start the web API. I don't think you heard me, computer. Start the web API. Maybe it's just building. Anyway, let's switch to the client and start the client. Here's my Swagger UI. Is it running? Yeah, that's right. So now I go to the home page. Oh, I got a result. These are the JSON that I get from the weather API. If I logged my token. So here's my token. Everyone can read that, right? Now that we got a token, let's see what a token looks like. jwt.ms. Which is a nice little site for decoding your tokens. It never leaves your browser. It does the decoding internally. It is 3 strings, base 64 encoded, separated with a dot. You see different colors all the way up to the right there. There's a dot. So that's the header. Then there's the actual token, and then the green part at the bottom here is the signature. It says this token was issued by Azure Active Directory. It can tell. This is what the token looks like. It has an audience, which is this token is meant for this API. It has an issuer. It is issued by Security Token Service, Windows.net, at this tenant. So I can tell which tenant it comes from. Bunch of timestamps, issued at, not before, expires at, some ID specific keys, the app ID, my email, my family name, given name. My email is my given name according to Azure AD apparently. And a bunch of stuff here, including a subject ID. The subject ID is the ID of my user local to this particular app. So I can use that to keep track of, to recognize me as a user in this app. I cannot use it to cross-reference a user across apps. But is guaranteed to be unique and persistent within this app. I have OID, object ID, which is the object ID for my user in Active Directory. It is guaranteed to be unique and persistent across all apps. So I can save that and be confident that I can get back to my user. If all of these aberrations look weird, you can always go to claims, and it will let you know more about these. So, what's next? Oh, now daemons. I promised we'd look at daemons. A daemon, spelled D-A-E-M-O-N, is the traditional name of a service that runs without a UI. It runs on its own, and sometimes it needs to access other resources. Now, we want those accesses also to be authenticated. So again, we can use the traditional Microsoft.web identity to set up a confidential client using a client secret or a client certificate. This is a console application. It has some stuff here for setting up the authentication. It gets a secret if you have it. Add them token cache. And it uses the acquire token for client. So it's a slightly different call. But then it does the same thing that we did. Oh, it gets the token from before. Let me see. So acquire token, it gets the token, and then it just calls an API with that token. The interesting part here is that it doesn't have, it cannot log on. So it cannot consent to stuff on its own. It cannot do an interactive log on. So what we do instead, we use something called app roles. So here's my to-do API, which has app roles called daemon app role. I can create an app role. I can say that who's allowed to use this app role. Is it just users or groups, just applications, or both of them? A value to it can be whatever I want, should be short and no spaces. A description can be whatever you want. Here I've made called one daemon app role. It's available for both users and applications. And in my console app here, app settings, I have this scope. API : / same form. This is the client ID for the API that I'm going to call. And the scope is .default. When calling APIs with app roles, you need to add .default as a scope, and the token will then come back with whatever roles you have on this particular app. You are granted these roles on this app. Here they are. And then I can, in my to-do list app, in my to-do list controller, can authorize, same as we've always done. It only authorizes, it doesn't do anything on behalf of my user, it only the client secret here. Add Microsoft Identity Web App, fine. I can also here validate my app role, which is an extension method in the web identity saying, validate the role daemon app role. saying unless you have this particular role, unless this role is present in your token, you're not getting in. So let's run the web API. There we go. Let's run the console app, which has a secret, so it's a confidential application. It can get a token on its behalf as itself, not as me, not as someone else, but as its own identity. And we see it gets some data here: pick up groceries, finish invoice report, and water the plants. Pretty eclectic task list. Now I've been making my own application registrations. In Azure, I can also, let's go to resource group, and you see London. Let's find, let's go for this one. I can go, anyone who's been here before, web app, and this is a web app service. I can add what's called a system-assigned managed identity. It's a matter of turning that on, and Azure Portal will automatically create an app for me in Azure AD. It will put it up here. There's the object, the principal ID of that app. And I can give it role assignments. I can use this app, or I can assume the identity of this app by calling, let's go to this one, this particular call. Now I'm using another library called Azure Identity. And I can do Azure Identity default Azure credential. It returns to me a set of credentials. And I can now ask for tokens from that credential. Credential get token. Where do I want to get the token? In this case, I'm getting for database. I can use this token to access Graph API, to access my own APIs, or in this case, access Azure SQL Server. And I'm going to have my service, and we don't have time to go through that, but I can have my service be granted, its AD user can be granted permissions in my database, and it can access the database, in this case through EF Core, with a token instead of a connection string with username and password. Which is a lot more secure because then you don't have username and passwords to your production data laying around. If someone gets into your configuration store, they cannot get to your data because the actual machine running it is the one with the permissions, not a random username password combination. We use this in our functions. We use Azure Functions to call APIs. The function has its managed system identity. We use Azure Event Grid, which has its own system identity, which is allowed to call webhook endpoints in some of our APIs. So instead of having connection strings with username and passwords, we can use managed system identities and have my code assume the managed identity that the service is running on and ask for tokens on its own behalf. Right. Any questions? I think I'm out of time. At least I spent an hour, so I'm thinking I'm out of time. Yes, over there. Yep. How do you actually talk to the service in Azure? I log on either through Visual Studio or through the command line with AC login. And the command here, so the question was, how will I debug this locally? How will I use it? The default Azure credential will also pick up my local credentials if I'm logged in through Visual Studio Code, or with AC CLI PowerShell as well. So I do on my workflow, I do AC login. I log in and then I run my app. Default Azure credential will pick up my local credentials as my user. I can also use set some environment variables with client ID and client secret and pretend to be another principal in the ID on my local computer. So there's two ways of doing it. My workstation is connected to Azure ID, so we'll just use my login. Or you can specify through environment variables, use this particular principle. Did that answer your question? Yes, sorry.
When you're setting up your app, you chose only in my Active Directory.
Yep.
But then the second option is any Active Directory.
Yep.
Truly any Active Directory, or is there something else going on there? Say, well,
it is in principle any, but you can pick and choose which one you want to allow. In your code, you can specify who you want to have issue. You can filter on issuers. So notice when we looked at the token, there was a field called issuer, and it contains the tenant ID of whoever issued the token. So I can allow from anyone in AD to give me a token, but then my code can filter, so I will only accept tokens from these three issuers, for instance.
Use case I was thinking, we have Azure B2C.
Yep. Yes.
Obviously, we have the business one with AD as well. So I could set it to multi-tenant and then pick if I wanted to do something here.
Yeah. I haven't tried that particular scenario, but yeah, that should work. So the question was, if you have Azure B2C, can you use that as a tenant to log on to this app if you allow it from multiple tenants? And I think that should work because Azure B2C is just another tenant. So I think that should work, yeah. So you could also set up different authentication schemes. So if you want, what you would do if you have web API and web pages in the same one, you would basically add multiple of these add authentication, with just different schemes. And one for web API and one for logging on. I think you could do the same thing with the B2C. You could have one that authenticated B2C customers and one that authenticated your internal Azure customers. Other questions? Right, okay. If anyone wants to talk more, I'll be here. So that's it for me.